Welcome all to this forum life made up of questions. Today, our resource person is uh, Professor Dr. Shantanu Baumik. He's a professor at the Department of Aerospace Engineering at School of Engineering, Amrita Vishwavidyapitham, Ettimadi, Coimbatore, India, and adjunct professor, Center for Future Materials, University of South Queensland, Australia. He's having several publications to his credit, more than 160 publications on top index journals. His research areas includes nanocomposite adhesive bonding and surface engineering related to aviation, polymeric composite, space and nuclear applications. Then he has developed these indigenous technologies like advanced thermoplastic composite for space radiation, shielding, and spacecraft structures for long distance space applications. Then lightweight hybrid composite container for storage of nuclear waste. Then lightweight bulletproof composite. Then lightweight blast proof composite, ultra lightweight fireproof composite, recycling of plastic waste to plastic composite products like Clean India, Green India, and Make in India mission as a part of it. High performance adhesive bonding for aerospace, nuclear space, and defense structural applications. And his profile is a long profile. Anyway, I'll be sharing the profile in social medias. So I welcome you, sir, to this forum life made up of questions.
Thank you. Thank you very much. Thank you for your kind introduction.
Yeah, thank you, sir.
Yeah,
so this will be an interactive session, and this session must be beneficial for the students, because now on a student perspective, they are much fascinated about aerospace engineering. So what is the difference like mechanical engineering and aerospace engineering on a layman point of view, I mean, for students?
I can say mechanical engineering is a mother of all the engineering. Okay, so that's the fact. Even personally, I'm also a mechanical engineer of my undergraduate, postgraduate, and also for PhD.
Okay, fine.
And then in the aerospace engineering, so see, whatever the parts we manufacture or we fabricate, it's a core mechanical engineering. And also in aerospace engineering curriculum, I think 40 to 50% syllabus will be similar to mechanical engineering.
My question is that now, it's quite clear, but nowadays we can see the trend is totally towards computer science and information technology, and the core for on a student's perspective or student's interest is totally towards the IT domain, and the job also we can see more opportunities are available for this information technology. So what will be the future scope of other domain like electrical, mechanical, civil, electronics and communication? What will be the priority in future? What, as per your expertise, what do you think the scope of the other core branches?
It's a good question. I think this answer would be very clear and very straight. See, now we are talking to each other, maybe in this forum, because of computer and the information technology. It's true. But a computer to run, you require energy or electricity. So if there is no electrical engineering, can a computer run itself?
No.
So you need electricity. Okay. And electricity comes from where? It will be coming from the thermal, that is coal, or hydro, that is water, or maybe nuclear, or maybe that non-conventional. Until in India, still in India, that 70% of the energy comes from the thermal, from the coal. So thermal engineering is a part of mechanical engineering. So if you eliminate mechanical engineering, then there will be no electrical engineering. And if there is no electrical engineering, there is no electricity. And if there's no electricity, then there is no computer, no electronics, no information technology.
Exactly. Everything is interlinked totally. Now we can't think a day without connectivity, more or less. And the medical field or whatever domain we are moving, whether it's construction, everywhere it is interdisciplinary.
Even if there is no mobile phone or say no computer, one can survive nicely. But if there is no water or if there's electricity, how long we can survive?
Exactly.
The core engineering will remain, and this demand will never come to end.
Exactly, exactly.
Yeah.
So now coming to your personal expertise, I had gone to your profile. So it will be very valuable to share your knowledge and your expertise with your students also regarding, as we know, an aeronautical engineering, there are a lot of materials used. So regarding, can you give an idea regarding the aerospace materials like metal alloys or weight and dimensions, everything? What are the main concept of aerospace materials?
Yeah. See, for the aerospace engineering, the structure, okay, the structure actually is made on materials. It may be the fuel stage, or it may be the wings, or maybe the nose, or maybe the that tail, whatever. It's made of the materials. So these materials were essentially till 1970s, it was a steel structure. Then from 90s till 90, it was an aluminum structure. Then from the 90s onward, it's a polymeric composite structure because lightweight materials. So that will be energy saving, more efficient. So I'm showing you one such of that composite structures, which is used for the aircraft structure. And it is having a very high strength, and its density is only 1.3 gram per centimeter cube, which is 1/5 of steel and less than half weight of the aluminum. Okay, so that means this composite materials is the future for the aerospace engineering structures. And if you see today's aircraft, which has been manufactured by say Boeing or Bombardier Aerospace or maybe Embraer, the big companies, it will be definitely 60 to 70% of the composite materials for the structures. So in this case, or in the case of aerospace engineering, there is a huge requirement of knowledge on materials engineering at the same time for the mechanical engineering.
Nowadays, sir, everywhere we can see the simulation side. Actually, the hands-on feel for the hardware side or the material side is declining. Not totally, on some trend, because when we are going for the projects also, everywhere the coding or the simulation tool, they are mainly focusing, like any materials being designed. All the technology can be evaluated using the mathematical modeling, and the simulation they will be evaluating. So how the real feel or the exact hands-on, how we can feel that? What is your view on all of this?
See, okay, that suppose if you have a computer graphics simulation, say an aircraft structure, can you fly with the graphics from say Kochi to Delhi?
Never.
You cannot, no? You need a real structure. Fine. You need a real aircraft to fly, say, from Kochi to Delhi or maybe Coimbatore to Mumbai. So whatever simulation we do in the lab, which is that to see that how it will be working in the real field. So simulation is absolutely is important, no doubt about that. But ultimately, it has to come to a manufacturing.
Exactly.
Okay, unless if you manufacture an aircraft, then what you will do with the simulation?
Because everything is linked with the computational now. That's why I made this question. But actually, at the end of the day, in order to get a product, as Sir has mentioned, I mean, a computational won't work totally. We need to create the product.
Ultimately, you have to have the product.
Yes,
that
exactly.
computational, that modeling will be actually helping you out how efficient the product will be.
Exactly.
Suppose if I do the computer simulation of this, okay, this is the aircraft structure, that how efficient it will be, that we get the mathematical modeling or the computational modeling, and based on that we manufacture in the plant. So unless you manufacture, you cannot have the aircraft.
Exactly.
Okay, and for making an aircraft, we will need to have the basic strong knowledge on aerospace engineering, mechanical engineering, materials engineering, electrical engineering, and all.
Because everywhere the material is coming, because we are having metals, semiconductors, then all these different classifications.
Everywhere.
Metals are coming.
Even see that you are seeing me, I am seeing you through computer, no?
Yes.
It's also a material, no? The computer is a plastic material.
Exactly. So when it comes to aerospace materials, we are having the other terminologies like space materials and defense materials.
Right.
So what makes the difference in that materials? We are adding that space and defense. What differs from the aerospace material.
The aerospace materials, whatever you see here, this we actually apply for the structure. Okay, and now let me explain that when an aircraft starts from the airport, say the temperature around the ground is around say plus 40 degree. Okay, and when that aircraft flies with a height of say 35,000 feet, there the temperature is minus 40 degree. That means this material will have the window or capability to withstand temperature of say plus 60 to minus 60.
Okay.
Okay, and this is for the structure of aircraft. And then I think you can see here, no, this is a composite material. You can see that 5
Yes.
firing of bullets.
Yes.
I think you can see here, no?
Because it's visible.
And you can see the back, all
Yes,
the bullets are stopped. All the bullets are inside.
Yes.
Fine. That means this we can actually use as a bulletproof vest.
Exactly.
Lightweight bulletproof vest. Okay. So this is also a material based on plastic or polymer and the fiber. This is also a material based on plastic or polymer and fiber. But this particular material is using for the structures, and this particular is we are using for the, say, for defense application.
Okay.
Okay. So once again, I am coming to that computational that way and the manufacturing way.
Yeah.
Suppose if you make a good computer videography or this, that bullet is coming and stopping here, but ultimately you have to have this bulletproof vest, no?
Yes.
It
Exactly.
has to be manufactured properly.
Yes.
Okay. So mathematical modeling will help us how thick it would be, how many layers, okay, that thing. But ultimately that it requires a process engineering or a strong knowledge on materials engineering and the mechanical engineering to manufacture this. So there is no way that we can skip the core engineer. Fine.
Yes, exactly.
Then I am coming, the another one, maybe you can find in YouTube also. This is also a particular material, very lightweight. Also, there's a video on YouTube is available, and it won't catch fire.
Okay.
Even if you plus petrol, if you pour in kerosene, it will not catch fire.
Okay.
Okay, and it's very light in weight. If you throw a huge chunk of stone on that, it will not even damage. Such a high impact resistance.
Okay.
So this trial we did in Siachen Glacier with the Northern Command of Indian Army. We made a habitat bunker. So you know that in the higher part of Himalayas and the altitude of 18,000 or 21,000 feet high, where temperature is say minus 40 or minus 50 even. Okay. So outside it's minus 40 temperature. Inside it will remain plus 10 or plus 12. It will remain warm. And it will not catch fire. Okay. So therefore the structures or the habitats or the bunkers can be made with this material, lightweight materials.
Yes.
So again, once again, maybe in the movie or in the computer, there is a maybe that no flame, but it is not catching fire. But practically, we have to make it.
Yes. Exactly.
Okay. So there it stands that this is also in aviation and the space and the defense materials, which won't catch fire even if you put petrol or kerosene. So that at the end, there is no way one can avoid the core engineering like mechanical engineering, electrical engineering, civil engineering. It's no way. Or electrical engineering. Oh, yes, all those engineering.
Yes, sir. So ultimately, you were telling about all these combination of materials also. There comes
this combination.
Yeah, there comes plastic. So plastic also you are mentioning. So when we are speaking about plastic, we are always thinking about the pollution.
No, actually, no. Let me also tell another important aspect for the student. No, they may not understand this at this early stage. Suppose if an aircraft, if you see in one full aircraft, or maybe a full a full automotive car. See, in the full automotive car or full aircraft, how many engineering is involved there? First of all, the mechanical engineering, the design. Second, the materials engineering. Third, what will be the structures of this is aerospace engineering. Then if you see the cockpit, where the pilots operate, it's electronics engineering. Then how it has been monitored from the ground is a computer engineering. Then when it's going to the, that in the sky is a physics. Okay. Then when that it is encountering the environment, it's a chemistry. So in one aircraft itself is a combination of 9 or 10 engineering and science domain. Okay. So nothing is that is separate. Like in a human body, we have heart here, lungs here, kidney, liver, brain. If one stops functioning, can we function well?
Never.
Never, no? So it's a harmony of all the organ, and then the human body is functioning. Similarly, it's a harmony of all the engineering knowledge or the scientific knowledge, making the full aircraft or spacecraft or missile to function well. That's I think my my answer to the students. So don't eliminate the one from other. It's a harmony of all the engineering knowledge, and that is coming to a real product.
Because
Yes, your next question, I think you asked.
Yeah, now this plastic based or plastic composite products. So when we are using plastic waste, already we are thinking about recycling of plastic waste. And what is the real applications of this plastic in aerospace or all the structures or any other material combinations?
Actually, let me show you. This is a plastic bag.
Yes.
Okay, with a carry bag. This carry bag, maybe we are using 1 hour or 2 hours, and we are throwing it out.
Yes.
Then similarly, say that water bottle from the plastic, we are also using the water, say that
So I think some connectivity issues are there. Hello. Is it audible? Hello. I think some connectivity issues, sir. It's muted, sir. Your sound is muted. Yes, fine.
Fine now, no?
Yeah, yes.
Okay. Now let me explain once again. This say potato chips packet, or the biscuit packet, which is outside is the plastic and inside is the aluminum coating. Okay. Then for the packaging, we are using thermocol for the packaging. Then I think every one of us, we are using this Tetra Pak, we are drinking and throwing it out. And you know how much of garbage we are generating per day from this plastic waste?
Yes.
From these waste plastics per day in India, we are generating 26,000 tons of plastic waste. It's a huge number, okay? And it's a country of almost now 140 crores. So 140 crores population, we are generating 26,000 tons of plastic waste every day in the environment, polluting the environment. We are polluting the river, mountain, soil, agricultural field, and also ocean. So the entire world planet Earth is polluted because of this plastic waste.
Yes.
And also know that in these days, if you do a common survey, the flood during the monsoon, it may be in Kerala, it may be in Mumbai, it may be in Chennai, or it may be in Kolkata, or it may be in Visakhapatnam. The flood happens because of choking of the drains. of these plastics, because the water won't flow, and which is creating a huge damage in the cities and the towns also, number one. And number two, I think all of you might have seen that the cows are eating those plastics.
Yes.
So, and that plastics, if the cow consumes those plastics, it goes to the cow's stomach. And if we drink those cows' milk, then the microplastics automatically is coming to our blood, and which is cancerous. So even unknowingly, we do not know that why, if now a healthy person being affected by cancer, despite the person may not take alcohol or may not have the habit of smoking. Okay. So this is I think the message must go to the society, to the students as such, that for a healthy reason, for the healthy living in the environment, we'll have to reduce the plastic waste from the environment. So how we have reduced? So now let me tell you, this say plastic packaging, or say this plastic bag, which we are just using for half an hour, we have collected this plastic waste and we have made this beautiful roof tiles.
Okay.
So it has gone to even the villages also. Right. We have made the roof out of this waste plastic. That means the plastic bag, which we are just using only for half an hour or 2 hours, it will have a life, if we have a roof tiles, so if we make from that more than 50 to 60 years.
Yes.
And these roof tiles, once its life is over, we can again melt it and we can make the next roof tiles out of it. And also from that waste plastics, we have made this ridge tiles, which is the top of the roof now that we put this. We have made this also ridge tiles. Then from the waste plastics, we also have made the pavement tiles. The pavement tiles, it can stay in the footpath or maybe in the side road, and even it can take a load of a truck or bus, nothing happens. So that means the plastic which we are throwing in just half an hour or 1 hour time, now it's a life of almost 50 years, such a useful product. So it will not only clean the environment, number one, but also it will create a lot of employment. And also it will create that lot of opportunity for the youths to come to a new companies to form. And it will be useful to the common people. Then I'm showing you this Appy or Tetra Pak or this Maja mango, which we are just consuming in just 2 minutes time. We are drinking and throwing it out. From this waste, we have made this beautiful sofa cushion.
Good.
Okay.
Yes.
So it is already having life of, I think, 2.5 years we are using. It may go even longer. So now we are making a blanket also. Okay. That means whatever the waste, it is not the waste, it's a wealth. If we know the proper manufacturing.
Okay.
Okay. So that the wealth actually, and from this technology with my students, passed out from the Amrita Vishwavidyapeetham, Coimbatore, they have 3 startup companies.
Oh, fine.
And they are using this knowledge. They're giving know-how to many people across the country. We are actually also, we are very keen to give support for the Clean India Mission, Green India Mission, and Make in India Mission. And you know that there will be a huge scope of employment, that those who will be collecting these plastics can get employment. Those who will be cleaning these plastics can get employment. Those who will be segregating, because it actually goes all together in the environment, will segregate, also will get environment. Then those who manufacture this product in the plant or in the industry also will get employment. Then the person who will be selling this one also will get the employment. And this is a pavement tiles you have to put in the floor or in the road, no, that one. So you require some mechanic who can put a cement and sand can put also get the employment. So there are 7 phases of employment with this technology. So this is also it's a make in India technology. So
Good.
now you understand
Yeah.
that. Okay, now let me give few more answers.
Sure.
So now 2 projects are going on with I think 3 more projects on with me on the PhD, particularly the electronic waste.
Okay.
See, the computer, laptop, mobile phone has its own life. Okay, like this mobile phone, we don't use more than 2 or 3 years.
Yes.
Similarly, laptop or computer or the television set, we use for say 5 or 10 years.
Yes.
Then where you will dump this? Where you will dump this so much of electronics? So that technology we are now developing, how we can recycle the electronic waste to a next product. Correct. And at the same time, like in India now, we do have a lot of applications of the solar panels because we have that climatic condition is very favorable for the solar energy. But the solar panel also having a life of say around 30 years. So what we will do with the solar panel once the life is, where you will throw it? It's a huge chunk of panel. So we are trying to solve that problem also, how we can recycle the solar panel waste. That means the manufacturing is the solution.
Yes, exactly.
We cannot really avoid manufacturing. And if we really do emphasize more on the manufacturing engineering, so I think now our economy is almost $3 trillion.
Yes.
Really aim for $5 trillion or $10 trillion in next 10 or 15 years. Okay, the highest economy in the world. Suppose if we really aim, so we have to go for the manufacturing of all these products.
Yes,
So
sir.
that
Yeah, fine.
so I would say all the students or engineers or the parents or the guardians don't only insist only for one group of engineers, because that does not give the complete country scenario or the solution. We really require computer scientists, we really require information scientists, we require mechanical engineer, electrical engineer, electronics engineer, materials engineer, good physics, chemistry, good medical doctors, and also biochemists. We require all together.
So thank you, sir, for your valuable experience sharing with hands-on sharing of the material. You really give a feel for the students. I hope that this was a wonderful session. And I had gone through some of the indigenous technologies you have developed and the ongoing projects, as you have mentioned in the university, which will create several employability for a particular product, like 8 to 7 employability will be created. So it's a good eye-opening because we are never thinking about all these minute like sessions of this end result of a product. So thank you. And I'm also an alumni of Amrita. So it's a proud moment to have a session with Dr. Shantanu Bhaumik. So I hope that this will be very, very much beneficial for the students who are watching this session. And I hope that in future also regarding manufacturing, and you will be getting more projects and more innovative ideas and projects will be coming from your side for better India. So thank you, sir. Thank you. Thank you.